I'm just going to grab a regular piece of paper. You do not need to write any of this down, but I would like you to follow along. So, for example, we all know that if you have a number like 2 to the third power, that means that equals 2 times 2 times 2, right? Anything to a power just means something multiplied by itself, however many times the exponent says. 5 to the fourth power would equal 5 times 5 times 5 times 5. So it's just the number multiplied by itself, however many times the exponent says. You learned that, I'm probably sure, back in like middle school, maybe even before that in grade school. So what we're dealing with today is what happens if you end up with something like 2 to the third power times 2 to the fourth power. Good morning. Eiley, I'm going to check on the seating chart real quick because we do have a seating chart, and I'll let you know where you're at. So, Eiley, you are in this row here, fourth seat back, right in front of Devin. All right. So if we have something like 2 to the third power times 2 to the fourth power, we know that 2 to the third power is 2 times 2 times 2. I'm just going to write equals here. We've got 2 times 2 times 2. And it's all connected by multiplication. So if we multiply by 2 to the fourth power, that's another 4 2's after that. So here's 1, 2, 3, 4. So these first 3 here, that would be 2 to the third times, and then the 4 after that would be 2 to the fourth. So how many 2's are there total? Seven. Yeah, there's 7 2's. So this would equal 2 to the 7th power. And if you add 3 and 4, this would equal 2 to the third plus 4. So 2 to the 3 plus 4. 3 plus 4 is 7. And there were 7 2's all written out together. So what we're saying is this works with numbers, this works with variables. As long as you have the same number here, you can't do this with 2 and 5 and say something to the 7th power. That doesn't work because the 2 is different than the 5. But as long as you have the same number or the same variable and you're multiplying things together, all you have to do is add the exponents. And so the power rule says, or the product rule says, as long as that base value, x in this case, is the same when you're multiplying, you just add together the exponents. So for example, on number 17, because we're continuing on from yesterday, x to the second power times x to the third power, because these are both x, all we have to do to simplify this is to add our exponents. So that would be 2 plus 3 for the exponent. So the answer to this would be x to the 5th power, because we're just adding the exponents together. So as long as your variable is the same or your number is the same, you can add the exponents where there are exponents. So on number 18, we have a to the 9th times a. Does anybody think they know what that one's going to end up being? A to the 10th, good. And the reason why it's a to the 10th is because there's 9 of them here, and when there's an a by itself or a variable by itself, that's one more. And you can put a little 1 for your exponent, a to the 1st power, that's fine. And because they're both a, and we've got a 9 exponent there and a 1 there, we can add them together and get a, make sure I write a and not x, a to the 10th. So do number 19 on your own. I'll give you, let's say, 15 seconds. I'm not going to give much time for that because it should, at this point, be a pretty quick thing to figure out. All right, I'm going to get attendance done here too. So Alicia, thank you. Jimena is here. Evelyn is here. Jane. All right. Maddie's here. Elena's here. Alondra is here. So, all right. Esteban is here. Estrella. Tanner. Jordan. Okay. Bo. Let's see, Gabriella Jane. Gabriella Caller is here. Lily is here. Jaime. Ivy is here this morning. Justin is here. Lou is here. Caribe. Killian is here. Devin's here. Angel is here. Diego's here. Silas is here. Jose is here. Jesus is here. And Cynthia. Yep. Okay. Cool. All right. So what do we have for number 19? Somebody let me know. What is it? W to the what? What did you get, Sila? Number 19. 11, yeah. W to the 11. Good. Nice. Just add the 7 and the 4. Good to go. So that's the basics of today's lesson. As long as you have the same base value, you just have to add together the exponents and you're good to go. All right. The rest of these examples, though, we're going to use this idea, but as you can see, things are getting a little bit more challenging. And this is kind of where your calculator is going to end up coming in handy, because if you have something like on number 20, where it's 4x squared times 3x to the 5th, we got some directions right here. It says examples with coefficients. And once again, a coefficient is just a number in front of a variable. So on number 20, the coefficients would be 4 and 3. And what we are allowed to do here is, on this one, we are going to multiply the coefficients, meaning 4 times 3. And then we're going to simplify the variables with the product rule. So any variables that are the same, we're going to add those exponents with. So I just want to remind everybody that when you have multiplication, the order of multiplication doesn't matter at all. So if you have 2 times 3 times 4, that's the same as 3 times 4 times 2. It doesn't make a difference. Whatever order you multiply things in, it's going to be the same answer either way. So if we have something like number 20, 4x squared times 3x to the 5th, the reason why we're allowed to multiply the coefficients 4 times 3 is because we can rewrite the order however we want. We can say 4 times 3 times x squared times x to the 5th and just rearrange everything. We're not actually going to rewrite it like that, but the reason why we're allowed to just go ahead and multiply the 4 times 3 is because we could rearrange it however we want to make the multiplication work a little bit easier for us. So all we need to do on number 20, though, is start by multiplying the coefficients. 4 times 3, which is 12. And because the other two variables both are x, we can just add the exponents together. 2 plus 5 is 7. So the answer is 12x to the 7th power for number 20. So what I would like you to do is try 21 and 22 on your own. And I think what I'm going to do is I'm going to call on a couple of random people to let me know what you have on your paper. If I do call on you for an answer, just tell me what you got on your paper. And if it's not the right answer, that's okay. We're all practicing, we're all learning right now. So if we need to, correct what's on the paper, that's perfectly fine. Being correct is part of learning. Being incorrect is part of learning. And so if it's not right, it's not a big deal. All right, go ahead and get some answers down there, and we will start going through this here. So, good morning, Jordan. We're working on the second page of notes that you got yesterday. If you don't have that anymore, I can get you another copy. Okay. And I forgot to mention again, if you are needing a pencil today, feel free to grab one. They're on top of the bookcase over here. If you don't have one with you, go get one. Welcome. All right. So the way that I call randomly on people is I just use this calculator to come up with a random number. And so I've got a number next to everybody's name. So I'm not actually choosing anybody. I'm just using my calculator to do it for me. And let's see, we got 29 people in the class. Show you how that works. So there's actually a cool function on these calculators called it's called random integer, and it's abbreviated randint, and you can come up with a random number between whatever you want. So between 1 and 29, number 15, that is Gabriella Toller. So for number 21, what did you come up with? 15x to the 8th power. Good. So all we have to do here, multiply the coefficients, the regular numbers. 3 times 5 is 15. And then because those variables are the same, we can add the exponents together. 6 plus 2, x to the 8th power. Awesome. Let's see, next person is going to be Jordan. You just showed up. So I'll talk you through this real quick. Basically, what we've learned so far is that when you multiply monomials together, we can just multiply the regular numbers 5 times 6, which would be what? Yeah, 30. All right. And then because these variables are the same, we can put those together as long as we add together the exponents. So we get x to the what? Exactly. So 30x to the 6th power. Nice. And you're all caught up. So that's where we're at right now. 22, we got that one done. Now, the next 3 problems, these ones are getting a little bit bigger because we have multiple variables this time. And it's not going to change how we do this, though. The process is exactly the same. So on number 23, we're going to take our coefficient values, -4 and 3. We'll multiply those together and get -12. And then we're going to find everything with an a and add those exponents together. A to the 3rd, a to the 2nd, add those exponents. 3 plus 2 would be a to the 5th. And then we have b and b to the 5th. B by itself would be b to the 1st. So 1 plus 5 gives us b to the 6th power. So -12, a to the 5th, b to the 6th. So multiply your coefficients, multiply your regular numbers, add the exponents of the variables that are the same. So number 24. We've got 2 negative numbers multiplying together this time. -7 times -4, that's a +28. And we have p to the 9th here, and we have p to the 2nd here. So we'll add the 9 and the 2, get p to the 11th. We have q to the 3rd here, and q to the 6th here. 3 plus 6 would be q to the 9th power. And then we have r and r to the 4th power. So 1 here, 4 here, so that's r to the 5th power. All right. Let's see. I'm going to give you, see how quickly we can do this. Let's say 3 minutes. I'm going to give you 3 minutes, and I'd like you to go through number 31. So try to get from 25 to 31 over the next 3 minutes. So use a calculator for the multiplication if you need to. And after the 3 minutes, I'm going to go ahead and just keep calling on random folks to see what we end up with. And if we need to make adjustments and corrections, that's totally fine. I just want to make sure you're trying and practicing. And if you have questions as we're going through this over these next 3 minutes, please raise your hand, let me know. I'm happy to come around and give you some help if you need it. So 3 minutes, see what you can come up with.
Why would be that sort of function? Three numbers to multiply together on number 26. Yeah, is anybody going to see a calculator? I do have some extras as well. I'll let you know that once we're done. Yeah, good question. I'm going to talk about that. Let's see. Anybody else calculator? All right, I got some more over here. Yeah. The coefficient number. So for number 27, I've had about 4 questions already on number 27.
To help you get started on that one, the coefficient for this first set of parentheses, the number would be a 1. And this number in the middle obviously is a 6. And this one over here would be a -1. So for your regular numbers, you can do 1 times 6 times -1. And then you can work with the variables after that. So it's just like what we've been doing earlier in the year. If there's no number in front of a variable, it can always be a 1. Up another minute or so. Okay, so number 25. Let's find out who's going to help us out with number 25. That is going to be Sila. You have something for 25? Exactly. Nice. So for number 25, we've got -24 because 8 times -3 is -24. And then x to the 8th power because x to the 4th and x to the 4th. Add the exponents to get 8. And then y to the 11th would be the y to the 2nd and y to the 9th. Add the exponents to get y to the 11th. Excellent. And if you have questions after we write an answer, if you want to know, like if something doesn't quite make sense, you need a little bit more explanation, please let me know. I'm happy to help out with that. But that's it for 25. Nice job. So number 26. Let's see. Hey, Jane. Jane, 26. Negative 30 times y to the, I see the 2 plus 3 would be 5. And then this one right here also has 1, even though it doesn't have the number shown. So we're just going to turn that into a 6 instead. Okay. Nice. Good work. So 26, negative 30, y to the 6th. So 2 times negative 5 is negative 10. And then times 3, negative 10 times 3 is a negative 30. And then the y by itself is like a y to the first power. 1 and then 2 and 3. So 1 plus 2 is 3, plus 3 more would be y to the 6th. Awesome. Thank you. 27, that was that kind of tricky one because of the coefficients or lack thereof. So that is going to go to Jesus. Number 27. Yeah. Yeah. A to the 7th and B to the 3rd. Yeah, nice. Awesome. So 27 is negative 6, A to the 7th, B to the 3rd. So you don't have to put the ones in front of these, but if it helps you to have the ones in front of sets of variables that don't have numbers, it can certainly make things a little bit easier. 1 times 6 times negative 1 is negative 6. And we have an A here, so that's A to the 1st. We have an A to the 5th, so that would be 6, and another A here, so that's 7. And then we have a B here, so 1, another B there, 2, and then a third B over here, 3, so B to the 3rd for number 27. All right. If there aren't any questions there, we'll move on to number 28, and that is going to go to Devin. Fourth, y to the 5th. Awesome. That's it. Good. So our regular numbers, negative 2 times 3, that's our negative 6. We have 1x here. We have a second x here. And there's 2 more with that exponent. So there's a total of 4. We have a y here, another y here, and then an exponent of 3 there. So that's 3 more for a total of y to the 5th. Nicely done. All right. Number 29 is going to Esteban. So what's our first number going to be on number 29? When you multiply the 6 and the 7, what do you get? $42. Nice. And then we have an m here, which is a 1, and then we have 2 more here. So what's 1 plus 2 going to be? 3. All right, so m to the 3rd. And then what power are we going to use for n? Is that? So yeah, there's a 1 here, and then there's 4 more here for a total of 5. Nice. Excellent work. Thank you, Esteban. So 6 times 7 is 42. We have an m here, so there's 1 there. There's an m squared, so 2 more, so it'd be m to the 3rd. And then we have n, 1 n there. And then n to the 4th would be 4 more of them, so 1 plus 4 would be n to the 5th. All right, number 30. Justin, number 30. C to the 5th, D to the 6th. Good. Nice. 8 times 10 is 80. C to the 2nd, C to the 3rd, add the exponents. 2 plus 3 is 5. D times D to the 5th, add the exponents. 1 plus 5 is 6. Nicely done. And then the last one of the ones that I wanted you to finish, number 31. Let's see, already had that person, already had that person. Let's go to Lily. She took the pass. Oh, she got lucky. Okay. Let's see, Eileen, do you have anything for 31? Not yet? All right, let's take a look at it then. So what are our 2 regular numbers are -4 and -5. So what would that be if we multiplied -4 times -5? Same as just 4 times 5. 20, yeah, all right. So -4 times -5, positive 20. And then we have an r here, so there's 1. And then there's an r to the 4th there, so 1 plus 4 would be r to the what? 5th, yeah, so r to the 5th. And then s to the 2nd, there's 2 there, and then another s over here is 1 more, so 2 and 1 gives us s to the 3rd, exactly. Nice, thank you. So 20 r to the 5th, s to the 3rd. That's number 31. All right, are there any questions on the ones that we just went over before we finish up with our last 7? We've got 7 more to go. And then after that, you're gonna have the remainder of class to get started on the assignment. So it should be plenty of time for that. All right, hopefully we're feeling okay so far. So we're multiplying the regular numbers, we're adding the exponents. All right, 32, let's take a look at that one. -6a squared b times 1/2 ab. So our regular coefficient values here, -6 times 1/2. What's that going to equal? -3, yeah. Half of -6 would be -3. And then a to the 2nd times a would be a to the 3rd. And then b times b is b to the 2nd, or b squared. All right. Now, if you are wanting to use your calculator for the multiplication here, you are more than welcome to do that. -6 would be the negative button. And just a reminder on the negative button, it's the one by the decimal, it's not the minus. 2 separate values there. So -6. And then if we want to multiply that by 1/2, we have a fraction button on these calculators, and it's the one that is 3 above the 7. It's the n over d for numerator over denominator. You push that, it opens up a fraction. And you can just do 1 and then hit the down arrow and 2. So -6 times 1/2, -3. And you do fractions all day long on this calculator. And it's really convenient if you need that. So the next one, 33, 12y times 2/3 xy to the 4th. We're going to take our 12. We're going to multiply it by 2/3. What does that equal? 12 times 2/3. 8, yep. 12 times 2/3 is 8. Let's see, x first. There's only one x there, so we're going to have x, and then y. There's a y here, and 4 more there, so xy to the 5th. So 8xy to the 5th. Now, if you had 8y to the 5th x, that's fine. But as I mentioned yesterday, generally speaking, we'll write things in alphabetical order. I would not mark you down, though, if you wrote 8y to the 5th x. All right, and then number 34, 1/4 times 8mn times -6m squared n squared. What do we get when we multiply our coefficients together? Yeah, all of them, including the fraction. So yeah, 1/4 times 8 is 2, and then times -6. Bless you. -12, yeah. So 1/4 times 8 is 2. 2 times -6 is -12. All right. And we have an m here, so 1, and then m to the 2nd. There's 2 more for a total of 3, so m to the 3rd. And what will our exponent be with our n? N to the 3rd as well. Yep. Awesome. Okay. Now, these last 4 problems, it says mixed practice, because we are mixing what we learned just now with what we learned yesterday. So that means, just real quick here, we have to use, and this is really important. I'm going to write this off to the side under mixed practice. Use order of operations. So what that means for us is we have to do the multiplication before we can even try to add or subtract. Yesterday we did the addition and the subtraction, and we could only do that if we had like terms. And that's what we're going to try to figure out today. When we multiply our terms together, after we multiply them, can we add them together? Do we have like terms? If we do have like terms, then we'll either add or subtract the coefficients. If we don't, then we'll have to leave it as it is. But we have to use order of operations. We have to multiply first and then either add or subtract second. So anytime you're working through a problem, whether it's regular or with coefficients and variables, we still have to follow the order of operations. So with number 35, we're going to have 2x to the fifth y squared times 4x y to the third. So we'll multiply the 2 and the 4, which will give us 8. X to the fifth times another x would be x to the sixth. And then y to the second times y to the third would be y to the fifth. Over here, we're going to do our multiplication. So we have 3 times, that's a 1, so that's just 3. So let's see, plus 3. X to the fourth times x squared is x to the sixth. Y to the fourth times y is y to the fifth. So as long as we have the same variables with the same exponents on those variables, that means we have like terms, which we do here. Y to the, or x to the sixth, y to the fifth. Which means we're allowed to do what we did yesterday, which is just to add together the coefficients. 8 plus 3 is 11. So the answer here is 11. X to the sixth, y to the fifth. And based on what we learned yesterday, remember, I'll bring this back in just a second. You are not going to change the variables and exponents when you add or subtract. You only change the variables or exponents when you're multiplying, or as we'll learn tomorrow, when you're dividing. So our answer here for number 35, 11x to the sixth, y to the fifth. All right, the next one we're going to do is 37, and then I'm going to have you do 36 and 38 on your own. So here we go, number 37. The nice thing about 37 is that this first term here, there's nothing to multiply it by, so it just stays as it is. So 19, m to the 8th, n to the 8th. 4 times 3 over here is 12, so that'll be minus 12. Got it. So minus 12, m to the fifth times m to the third would be m to the 8th. And then n times n to the seventh is n to the 8th. So once again, we do have like terms here because it's m to the 8th, n to the 8th. And so we're just going to take 19 and subtract 12, and that'll give us 7. M to the 8th, n to the 8th. And that's our answer right there for number 37. So what I'd like you to do, take a few minutes, work on numbers 36 and 38. See if you end up with like terms or not, and then combine the like terms after you've done your multiplication, if there are like terms. And I'll check back in a couple minutes, and then you'll get your assignment, and you'll have the rest of the class to work. Let me know if you have any questions on those two. Oh, that's the alcohol. So if you want to check, see what happens after the multiplication, feel free to take a look up here. The answers aren't there yet, but the first step is. So 36. Somebody want to volunteer and answer on that one? I won't call anybody randomly this time, but if you have an answer that you'd like to share, Justin, what do you have? Good. 18 a to the fourth, b to the sixth. Awesome. So we ended up with like terms again on that one, 20 a to the fourth, b to the sixth minus 2 a to the fourth, b to the sixth. Or if you wrote plus negative 2 a to the fourth, b to the sixth, that's fine too. 20 minus 2 is 18. We keep the variables and exponents the same. On 38, the multiplication of the first two gives you 15 c to the fifth, d to the second. And on the second one would be minus 14 c to the fifth, d to the second. So we do have like terms here. And then last one, somebody else. What do we have for our answer? Luke. Yeah, c to the fifth, d to the second. Or if you want, you can have the 1 in front of it. 1 c to the fifth, d to the second. Either way, for number 38, both 100% correct. Nicely done. All right. So that is it for our first lesson of Unit 6. So what I'm going to do is get your assignment handed out. It is just one side of a piece of paper, not even a two-sided one. And right now we're looking at about 25 minutes. So we've got a lot of work time. So just kind of talking about what what I was introducing you to yesterday. The expectation is that if we have work time, which we do right now, we've got a lot of work time, that you're getting work done. If there are people in the room that you would like to work with, you're welcome to get up and move around and work with other people. I'm totally fine with that. If you would like to listen to music as you're working today, that's fine too. The one thing I would ask is wait until all the papers are handed out, and so you get up and move around if that's what you choose to do. So go ahead and take the paper, pass it back. And then actually, there are a couple things that I want to mention before we get started. Seeing as this is the first assignment. Yeah. So the first 12 problems on here are like what we did yesterday. The next 9 problems are multiplication, and the final 4 are a combination of both, just like we saw. For assignments in this class, the way that it works is as long as it's completed and you've shown a little bit of work where you can show work, you get full credit 5 out of 5. Every assignment in my class is worth 5 points. If it's done and there's a little bit of work shown, you get 5 out of 5. I usually collect assignments the next day. So this assignment will be collected tomorrow. And then when you turn in an assignment or a syllabus for that matter, I've got turn-in baskets over here. Yours is third grade, so you just turn your syllabus or this assignment into the first grade basket. And then tomorrow when we show up, first thing we're going to do is go over the answers to this assignment. And that is for you to check the answers that you have on your own paper so you can kind of correct your own homework. And if you have questions on the assignment at that point, you're welcome to ask. We can go over anything we need to in detail, and then I'll have you turn it in after that. And then we'll get into the next notes once we go over the answers tomorrow. So go ahead and get working. Again, if you want to get up and work with somebody, you're welcome to do that. Let me know if you have any questions, and we'll be out of here in about 24 minutes.